We've spent 2 lectures on the Geom4 detector construction and visualization. However, a Geom4 simulation does not start with a detector. Instead, it starts with a particle. The particle may have some initial momentum, which allows it to fly from its starting point to the detector. It may also just decay at rest, and its secondary particles may reach the detector. In any case, the first particle from which the Geom4 simulation starts is called the primary particle, and its starting point is called the primary vertex. Geom4 tracks a particle step by step as it passes through the simulated world until it goes out of the world, or gets absorbed in the material, or changes to other particles. A step point is a point in the particle track where the particle is generated or changed. Note that Geom4 artificially adds step points on the boundary of 2 volumes when the track goes from one volume into the other, even if there is no change of the particle. Here are 2 other examples. In gears, the primary vertex, or the point from which the primary particle starts, are saved as all other step points into an array, but with index 0. Geom4 provides a simple tool called G4gun to specify some basic aspect of a primary particle, such as its starting point, initial momentum, type, so on and so forth. Geom4 also provides a more powerful tool called General Particle Source, or GPS in short, to specify some more complicated aspects of the primary particle, such as the shape of a radioactive source from where primary particles start. A few lines of C++ code in your Geom4 application would allow you to use the general particle source to generate primary particles for your Geom4 simulation. After that, you don't have to deal with C++ anymore. Instead, you can use GPS command in a Geom4 makefile to specify different aspects of your primary particles. To learn the usage of Geom4 general particle source, we'd better start with some examples of it shipped together with the Geom4 source code here. It is available online in the CERN GitLab Geom4 repository. There is also an outdated web page where some of the examples are missing. However, it does visualize the final effects of a specific set of GPS commands. It may be more intuitive to understand for beginners than the general particle source in the Geom4 menu for application developers, which, by the way, is a great reference for advanced users. GPS macro commands are explained in detail in the same menu. You can also find an ASCII version of the same menu in the Gears website. Most of the visualization methods mentioned in previous lectures that are used for the visualization of detector geometries can also be used to visualize trajectories of particles generated from the primary vertex. In this example, gamma rays are isotropically emitted from the origin of the simulated world. This can be achieved by adding trajectories to the visualization scene where the detector geometry is visualized. You can then use the run beam on command to start the simulation. The number following the run beam on command specifies how many events that you'd like to simulate. Based on the GPS setup here, a 1.2 MeV gamma ray is emitted in a random direction from the origin of the simulated world. Normally, each visualized event is saved in a separated picture. However, you can use this command to accumulate a few events in the same canvas, which would allow you to see the overall effect. This is another example. In this example, 2.6 MeV gamma rays are emitted randomly in a specific range of solid angle. Particle trajectories of 10 events are accumulated in this view. In one of them, the primary gamma rays got scattered by an electron, the trajectory of which is shown in red. In general, neutral particles are shown in green, negative particles are shown in red, and positive particles are shown in blue. The directional and position information can be displayed this way. However, some of the information cannot be visualized easily this way, such as the energy distribution of the primary particles. For example, if you'd like to simulate neutrons coming out of a americium beryllium source, you can use the GPS histPoint command to specify the bin location and contents of a user-defined energy histogram taken from a scientific publication. Such information can be retrieved from Geant4 output file and displayed as a histogram, the procedure of which will be introduced in one of the following lectures.